Have you ever wished you could fix bugs and add new features to Godot? It is easier than you might think. Here, we will see how to create a new feature from scratch and go over all the steps on how to submit it to Godot. Here's what we are going to improve. If you ever tried using a Path3D node before, you quickly realize they are very frustrating to work with. The points doesn't snap to floors and are often behind the meshes. And this makes a very painful experience to put them where you want. So we are going to fix that. We are going to add an option to make new points snap to colliders. It shouldn't be too difficult. In the first part, we have learned how to compile Godot, how the issues workflow work, install Git, and created our own fork of Godot. So now, let's open our Godot folder and create a new branch. You can do so with the git bash by typing git checkout -b snap to collider. This will create a new branch for our code to live in. You can see the green text here that we are now on the Path3D snap collider branch. If you are using GitHub Desktop, you can click on the branch Dropbox, type the branch name, and press new branch to do the same. First, let's figure out where we are going to make the changes. By convention, Gizmo's code are usually named something _ editor _ plugin. So we are going to look for the Path3D editor plugin, the code that manages gizmos for the Path3D node. But in case you didn't know that, we can search the code for things nearby. We are going to be adding a snap to collider option here. So let's search Godot's code and try to find the string mirror handle angles. Inside the Visual Studio, press Ctrl+Shift+F to search all the files. Make sure we are searching for CPP and .h files, and hit search. It seems we found our code. It's inside the Path3D editor plugin constructor. It creates a pop-up menu and uses the addCheckItem function to create the options, and it uses the setItemChecked to set the start value. Let's hold Ctrl and click on the value to see where it's coming from. It seems the class uses an enum for the option, so let's add our new option there, handle option snap collider. And let's replicate the code that creates the checkbox. Change the name to snap to colliders and put in our new enum value. And set it to use a new variable called snap to collider that we are going to create. Control-click on the mirror handle variable to quickly go to that area of the code, and let's add our new snap to collider boolean there. Now, let's compile and see if it works so far. Our new option is there, so that's good. But clicking on it doesn't change anything. And that's because all the options are handled inside the handle option pressed function. So let's go over there and add our new enum entry to update the checkbox value, the same way as the above ones. Compile Godot again, and let's see if the checkbox is working now. And it is. Now we need to actually make the created points snap to colliders. So let's take a look on where the Gizmo class handles its input. A common function used to handle input in 3D plugins is the forward 3D GUI input. So let's take a look at that. This here seems to be handling all of the mouse input. And if we scroll down all the way to the end, we find a section where a new point in the curve is added. And here's the reason the points are so badly placed. The Path3D creates a plane based on the camera and raycasts that to find where to place the points. So let's change that. If we have our snap to collider option enabled, we are going to cast a raycast and place the point where it hits something. I never use raycasts in C++, but it shouldn't be too different than when we are doing it in GDScript, and we can always look around the code for examples. So after seeing some examples, it seems C++ needs to declare a ray_result variable to get the values out of the raycast, but otherwise it's all the same. So let's move the plane down and check if snap to collider is enabled. If it is, we make a raycast with colliders based on the mouse position. We can get our physics direct space state 3D by getting our word 3D and calling get direct space state, and set our raycast parameters variable .from and .to values. Finally, we check for collisions with the intersect ray function, and use the same code as before to create our points, but pass in the hit position instead of our planes. Let's make sure everything's working before we clean up the code. And it's not working. So let's add the breakpoint and see why that is. I'll create one here near our snap collider, and click to add a point again. Now that we are here, let's step over and see what's happening. It seems we are doing the raycast, but something is not right. Turns out, I swapped the values inside the ray parameters .to. We need to start from ray from and add the radier times distance. Now let's compile and try again. And now everything's working. A feature that annoyed me for years is now fixed, as simple as that. So let's submit this change to Godot and see how that process works. But one quick tip, if you are unsure if your code is using the correct formatting Godot requires, you can select a section of the code, go to Edit, Advanced, Format Selection, to format those lines using the CLang format rules. You can also choose to format the whole document. Godot will break tests if the files are not formatted properly, so it is only your changes that might have wrong formatting to them. Now back to our git bash. Let's type git status to check our changed files, and use git diff to check what we changed, to see if nothing stands out. With the basic check done, let's add those files with git add editor / to get both files, and commit it with git commit -m add option to path3d to snap colliders. If you are using GitHub Desktop, you don't need to add the files like we did here. Just select the changed files and commit them will do the same. Finally, let's push it to GitHub with git push origin path3d snap collider, the name of our branch. And now our changes should be on our GitHub Godot fork. We can create a pull request to submit the code directly from here. But first, let's go into actions. When you push code to Godot, GitHub will start a GitHub action that will run all the tests and compile Godot for several platforms. You can click on the running action to see it running in real time. If your code has any problems, these tests will fail, and you can check here what were those problems. After a few minutes, the tests should be done, and they should be passing. But at this time, I noticed I made a mistake. I forgot to capitalize the snap to collider text. So after fixing that, we follow the same steps as before and add the changes. But Godot works with a single commit per pull request, and we already sent the changes to the cloud. To fix that, we are going to need to use a few commands. After we add our changes, we need to use git commit --amend. This will add the changes to the previous commit, and we open the last commit message on the bash terminal. If you don't know Vim, you can press ESC and then type :W key to write the changes and quit the file, and push the changes to the cloud again. But this time, we are going to use the -f option. This will override the changes on GitHub and use the local amended commit instead. If you are using GitHub Desktop, you can right-click the commit and choose Amend Commit to add the changes. This will also unlock the option for you to force push the changes to GitHub. The tests will run again, but they should be still passing. And with all that done, it is time to submit our code. If you saw the previous video, all submitted code needs to have an issue associated with it. And as we are adding a new feature to Godot, let's head to Godot Proposals and create a new feature proposal there. We quickly describe what it does and why it is important for it to enter Godot core, and hit create. Now we can wait for the feature to be tagged, and other people might write suggestions or concerns about it. And now that's left now is to create a pull request. So let's go back to my fork and create the pull request from there. You start by using keywords like fixes or closes, followed by the issue or proposal feature link. This will automatically link the pull request to those issues. Then I briefly describe what it does, and quickly scroll down and confirm the changes made. And finally, hit create pull request. Now our code is submitted and we just have to wait. An hour later, the PR is tagged and we got a code review and a suggestion. It seems the code is crashing if the option run physics on a separate thread is turned on. And testing this, it really does crash. But note that you need to restart Godot after activating this option for this to happen. The reviewer in this case even gave us a suggestion where to look. So let's do that. It is on the Node 3D Snap to Floor button. It seems when the action happens, it flips a variable and only executes the request on the notification function when the notification physics process happens. This is the equivalent of calling physics process in GDScript. So let's do just that. Now our input function unflips our new doSnapToCollider. And we added a new notification method to the path3d editor plugin. I also had to call setPhysicsProcessTrue on the ready notification, or else the physics process is not called. And the whole request now is on the execute snap to collider. A few things need to be changed to get the mouse and camera values, but it is in essence the same thing as before. So let's compile and make sure everything's working. Physics is running on a separate thread, and our request is working, even in different viewports. And we can disable and enable the snap behavior. And one more little change. If we don't hit any colliders, we use the default plane hit collision method. And with everything done, we review our changes add the files to Git, amend the commit, and force push the changes to GitHub. And it's done, our very own little feature. Now, right now, Godot 4.4 is in beta, meaning no more features can be added right now. Only bug fixes will be accepted. So this will take quite a while to enter Godot, and there might be other review changes to come. But I hope this shows you the whole process of getting fixes and new features to Godot, and you can get started contributing to Godot when the 4.5 phase starts. There is no better time to start when the new dev release is starting. But that's it. I hope you liked this video. Thanks for watching, and until next time.